Dinosaurs. They are among our most popular screen personalities. But what do we really know about them? What are the challenges facing paleontologists in the field? And why does it seem that we're always getting things wrong?
Being a paleontologist is like being a coroner, except all the witnesses are dead and all the evidence has been left out in the rain for 65 million years.
Dinosaur studies have long been riddled with controversy, intrigue, and a remarkable number of wrong turns.
There are so many misconceptions, of course, about dinosaurs, and one of the most prominent that we've had to deal with has been that they're big, sluggish animals.
Tyrannosaurus rex, it wasn't a slow, sluggish dinosaur. It was a scrapper.
They said Brontosaurus could never get out of the swamps. Well, I'll tell you, my gum, they didn't live in swamps. PhDs at Ivy League institutions were wrong.
Accepted theories have come and gone.
The early paleontologists thought of dinosaurs as being large reptiles, and that clearly wasn't the case.
Dinosaurs were lizards, they were birds.
While museums have been forced to rebuild their exhibits.
There's been some bad mistakes. There's been one for years in the American Museum of Natural History.
Everything we do in paleontology is disproven sooner or later. That's what it's all about.
Join us as we explore the missteps and mistakes along the rocky road of dinosaur discovery. It was their world long before it became ours. For more than 140 million years, dinosaurs dominated the Earth. But they have existed in the minds of man for a mere 160. The last of the dinosaurs walked here more than 65 million years ago. But they have risen from their graves and sunk their teeth into our imagination. What had once been the domain of a small group of intrepid scientists has exploded into a billion-dollar-a-year industry. In movies, museums, and mega events such as Dino Fest, the public has marveled at these bizarre creatures that defy the reality of today's world.
We have the concrete evidence, well, the bony evidence for these things, and they're magnificent structures. If you look at a skeleton out on the exhibit floor, it doesn't have any flesh on it. The skeletons themselves, they're like great bridges. They look as real without that skin. Just that structure is so compelling.
They're real monsters. We think we know that aliens are real. We think we know that ghouls and goblins are real. We think we know that demons are real. We know that dinosaurs are real.
This is a dinosaur arm, the left arm of a meat eater. And this object, this wonderful set of hooks, proves a fundamental truth. Dinosaurs are nature's special effects. They weren't made up by Universal Studios. This is not a dragon. This is not a griffin. This isn't mythology. This is reality. This is the finest wonder nature has ever concocted.
In recent years, we've seen an unprecedented explosion of new discoveries and theories. We've also begun to question many of the long-held beliefs about these extraordinary creatures. From the mid-1800s to the mid-1900s, paleontologists categorized all dinosaurs as large, lumbering, prehistoric reptiles. This was wrong. In the late 1960s, a new breed of dinosaur hunter emerged, and our overall impression of how these animals looked and behaved radically changed. This includes some of the classic dinosaurs we thought we knew. In pop culture, the Brontosaurus, with its long neck and massive girth, has always been one of the public's favorite dinosaurs. But its very name is a scientific mistake. A specimen of the same creature had been found a couple of years earlier and labeled Apatosaurus. And though many still call the creature Brontosaurus, by the rules of science, Apatosaurus has become the animal's official name. But that's not the only change this beast has undergone.
Well, there are so many misconceptions, of course, about dinosaurs, and one of the most prominent that we've had to deal with has been that they're big, sluggish animals, and no doubt some of them probably were. Clearly, animals like the legendary Brontosaurus. You know, they're often portrayed as animals that had to be in the water because the water would buoy up their great weight. We find that these were, in fact, land animals, much more like elephants.
Brontosaurus was always portrayed in the swamps, up to its armpits in fetid water. But when we started studying the Jurassic soil signatures, this old view was shown to be complete bunk. You don't find Brontosaurus or any of its relatives in a swampy, gunky soil. A swamp should be black. A swamp should be dark gray. This is not a swamp. It's a tropical forest and meadow and floodplain.
Other mistakes have had more to do with how the dinosaurs looked than how they lived.
There's been some bad mistakes. There's been one for years in the American Museum of Natural History, and that's the wrong skull on the wrong animal. We had a skull on our Apatosaurus skeleton that was really more like the short-faced Camarasaurus type of sauropod. And it was only a couple of decades ago that a couple of scientists said, well, that's the wrong head. As we renovated the fossil halls, that was a convenient time to switch the head, get the head right. We did admit to the mistake, but that wasn't intentional. It was a blunder.
Like the Brontosaurus, the 2-ton Jurassic giant Stegosaurus continues to be re-examined and revised. This dinosaur, with its distinctive bony backplates, was first described in 1877 by famed dinosaur hunter Othniel Charles Marsh. Marsh was working from a specimen that was so fragmented, he initially thought the plates lay flat over its back, like the shell of a tortoise. It wasn't until Marsh's field workers found a more complete and better preserved specimen that he realized the plates stood up along the creature's spine. But the question remained, what was their function?
One of the old ideas was that Stegosaurus, of course, had these back plates as a way to protect themselves against animals like Allosaurus. But in a way, it didn't make any sense because all an Allosaurus would have to do is bend over and come in from the side or go for the head. And the back plates wouldn't have been much protection at all.
Like a lot of theories, you can have two paleontologists with impeccable credentials disagree. It was speculated that the plates could have served as radiators or heat regulators for the animal, sort of like solar panels, or if it turned the plates to the sun because of the massive surface area on the plates, it could very quickly warm the animal up. If it needed to cool off, it could turn the plates against the sun as well.
Stegosaurus plates were used for display, not to generate heat, not to cool off the animal. None of those things. We've cut them, we've done histology on them, and there's nothing to suggest they were anything more than display organs, either defensive display or sexual display.
While the debate over the function of the Stegosaurus plates continues, our understanding of the most famous of all dinosaurs, Tyrannosaurus rex, has also been called into question. The creature has undergone several alterations in its anatomy and behavior since it was first unearthed a century ago.
Barnum Brown, of course, is the discoverer of the most famous of all dinosaurs, Tyrannosaurus, in the Montana Badlands, the Hell Creek Badlands. That place is an amazing place. You practically can smell dinosaurs when you're walking around there. That whole terrain is an extraordinary place. It just looks like perfect for a dinosaur graveyard.
If you look out here right now, what you see are a lot of hills, a lot of broken badland areas, a lot of pine trees, grass. Basically a very dry environment. But 65 million years ago, when dinosaurs roamed this area, the area was perfectly flat. There were palm trees, there were cycads, there were basically subtropical to tropical plants growing here. Dinosaurs would have been roaming all over the plains, tyrannosaurs, duck-billed dinosaurs, all these dinosaurs, and intermixed with them were a lot of the same kind of animals you'd find in the lower Mississippi right now.
Paleontologist Jack Horner has spent much of his career searching for dinosaur bones in Montana. Recently, Horner and his crew made an incredible discovery that should help shed new light on the Tyrant King.
The first Tyrannosaurus rex skeleton was discovered about 15 miles from here by Barnum Brown. He discovered it in 1903. And then this last year, we found 5 T-Rex skeletons within about a mile and a half from where I'm sitting. And before the end of this year, we will have at least 4 of the skeletons out of the ground. This is T-Rex capital of the world.
T-Rex is one of the species of dinosaurs that we can actually make informed judgments. We can look at lots and lots of teeth, lots and lots of arms and legs and skulls and vertebrae. T-Rex was over 40 feet long. The weight would have been 7, 8 tons. It was powerful hind legs, enormously strong hips, bird-like stature, and these bizarrely teeny forearms with only 2 fingers on them.
When T-Rex was originally found, it didn't have arms, and they made arms for it, and they made arms with 3 claws because they had an Allosaurus. It looked like it was pretty well related, and it was the best guess they could make. A few years after T-Rex was found, they found a thing called Gorgosaurus. Gorgosaurus had 2 little fingers and was more closely related to T-Rex, so they had a pretty good idea that T-Rex had short arms with 2 little fingers.
The 3-clawed arms were replaced by the 2-clawed arms fairly early on. But it is now believed that for most of the 20th century, the ever-popular Tyrannosaurus rex was mounted incorrectly in museums.
The American Museum of Natural History, Tyrannosaurus rex is really one of the iconic dinosaurs. That it's the one which everybody knows, and especially everybody knew it in its old position when it looked like Godzilla. It was standing up, its backbone was nearly perpendicular to the floor.
But there was one problem. If the T-Rex stood tall and erect, his long tail would be forced to bend backwards and break. So this clearly was not how nature designed the T-Rex.
When we redid the dinosaur halls about 6 years ago, we decided to put it in a more modern or active or anatomically correct position. Biomechanically, that's the only possible way that this animal could have walked. And if you think of walking as sort of the process of falling forward and catching yourself, an animal which is this large needs to have a big counterweight. So that counterweight is the tail, which stuck straight out behind it.
Now that the T-Rex has been correctly positioned, some paleontologists are investigating other possible misperceptions surrounding the Tyrannosaurus rex. For years, it has been portrayed as a swift and aggressive hunter, the perfect killing machine. Jack Horner isn't so sure. He wants to dig deeper and find specimens that will reveal the evolution of the species over its 3 million year existence.
I have hypothesized that T-Rex was a scavenger rather than a predator. And I think that if we find enough stuff in the bottom, enough T-Rex specimens in the bottom, compare them with the top, we'll be able to look for trends to see if T-Rex was actually selecting for particular characters that would help it be a better scavenger. Things like shorter arms or bigger olfactory or different leg proportions. A scavenger doesn't have to run, doesn't have to grab anything, it just needs to smell things a long ways away, like turkey vultures.
Jack Horner's contribution to dinosaur research is not limited to his work in the field. He has also served as a scientific advisor on the Jurassic Park films, where the T-Rex was presented as an unstoppable killer. But Horner has his own explanation for its ornery behavior on camera.
T-Rex chases a lot of things around, but he eats a lawyer, right? So certainly with the lawyer, I'd have to say that T-Rex was scavenging.
So lawyer is bitten and then spit out. In the second movie, I meet an actor playing me with the cowboy hat and the long hair. His is fake, mine's real. Gets eaten by T-Rex and is not spit out. So that's strong commentary, strong proof that I am more palatable than a lawyer.
Today's paleontologists can joke about being devoured by a dinosaur. But in the early days of the science, there were few laughs. It was a time when the study of dinosaurs itself was deemed by many as nothing short of heresy. For much of the 20th century, dinosaurs were thought of as one of nature's great failures. After all, these creatures had all gone extinct. Even the word dinosaur took on a negative connotation, meaning someone or something that had outlived its usefulness. But today's paleontologists consider that metaphor a mistake.
Dinosaurs were incredibly successful animals. They dominated the world for almost 150 million years. And for them to be so successful, they obviously had to have had a good formula for being that successful.
It wasn't until after the dinosaurs went extinct that our shrew-eyed ancestors began to evolve bigger and smarter and more dynamic, eventually leading to us. So if something from the outside hadn't wiped out the dinosaurs, we wouldn't be here.
When scientists first began studying dinosaurs in the mid-1800s, it had already been determined that the Earth wasn't flat or the center of the universe. But the study of prehistoric life confronted the public with two new faith-shaking concepts: evolution and extinction. When Charles Darwin published his theory of evolution, it met with fierce resistance. The notion of extinction was, for many, even harder to accept.
The idea of extinction was heretical. I mean, they would never, nobody would ever propose that God would create an animal that would become extinct because God was perfect. If they found the bones of an animal, it must still be around then.
The bones of dinosaurs and other prehistoric animals have been exposed by erosion for as long as man has been on Earth. Early civilizations in different parts of the world drew their own conclusions when they found gigantic bones or huge jaws filled with dagger-sized teeth.
You can imagine what the ancient Chinese thought as they came across a dinosaur splayed out in the ground. It looked just like dragons.
During Cretaceous times, the part of the world that is now the Gobi Desert was inhabited by small, plant-eating dinosaurs known as protoceratops. The discovery of their fossilized skeletons, more than 2,000 years ago, may have given rise to the mythological half-bird, half-mammal known as the griffin.
They have a bird-like beak, they have 4 legs, they have a long tail, and they have these very long, slender shoulder blades. And occasionally the skeletons will collapse and those shoulder blades will stick up really high. And that's exactly where the griffin's wings are supposedly attached.
Before science, it was often up to religious scholars to try and provide acceptable explanations for all of the giant, mysterious bones being discovered. One of the first was given by St. Augustine.
In North Africa, he saw a giant tooth, giant fossil tooth, probably a mastodon, big thing. A mastodon tooth looks a lot like a human molar, and he wondered how could there have been a human-like life form so gigantic and now extinct. He searched Genesis, and in chapter 6, he finds the description of these mystery people, hybrids between angels and people. They were evil giants, and they were wiped out. And he said, could this be?
Hundreds of years later, the question still remained unanswered. In 1677, an English reverend and museum curator named Robert Plott correctly identified a dinosaur fossil as a petrified bone. But he described it as the thigh bone of a human giant. It wasn't until the 1800s that people were beginning to accept the possibility that the fossils belonged to some strange, non-human animals.
As fossils began to be studied in great numbers, serious philosophers, Thomas Jefferson being one, looked at these fossils and said, what is the message there? Could nature allow wonderful animals to go totally extinct worldwide? And he told Lewis and Clark, when they went to the American West, be on the lookout for mastodon bones, for live mastodons, for mammoth turds, any evidence that these animals might still be alive somewhere.
Of course, in their travels across the continent, Lewis and Clark found no such creatures. Was it possible that certain plant and animal species had simply vanished from the Earth? The evidence seemed overwhelming, and by the 20th century, dinosaurs became synonymous with extinction. While some held out hope that a few survivors might still be found in an unexplored jungle, or in the depths of Loch Ness, such notions were most often dismissed as sheer fantasy. Then, towards the end of the 20th century, when just about everybody on Earth was convinced that all dinosaurs were extinct, scientists changed their minds.
If you want to find living dinosaurs, you don't need to go any further than just out into Central Park and look at the pigeons. Birds really are living dinosaurs.
Today, thanks to feather impressions being found in Asia, much of the exciting new work in paleontology is focused on the bird-dinosaur relationship. Most paleontologists are now convinced that birds are directly descended from one group of carnivorous dinosaurs. This radical new mindset not only changes the way we perceive dinosaurs, but also impacts the way we look back at the traditional history of dinosaur paleontology.
So we were feeling pretty proud of ourselves in the late 1990s. We had discovered this new thing, brand new thing. Dinosaurs weren't lizards, they were birds. But it's not a new thing. It's the original idea. The very first man to devote his life to the study of dinosaurs was the Reverend Edward Hitchcock in the 1830s. He studied dinosaur footprints. He didn't have bones. And from footprints alone, he figured out that what we call dinosaurs were in fact what he called a prehistoric subclass of ground-running birds who didn't fly, but had feathers covering their bodies and moved swiftly in packs and ruled the Earth in the Jurassic. That's a perfect description of Velociraptor.
But Reverend Hitchcock's conjecture based on footprints was completely overshadowed by the findings of another reverend on the opposite side of the Atlantic, who based his conclusions upon fossil evidence. In 1824, Reverend William Buckland of England described a jawbone and teeth that appeared similar to that of a monitor lizard. The creature was given the name Megalosaurus, which means great lizard. Around the same time, an English country doctor named Gideon Mantell discovered the teeth of another creature which he dubbed Iguanodon, because he thought they were similar to an iguana's. Once again, dinosaur remains were being compared to modern reptiles. In 1841, preeminent British paleontologist Sir Richard Owen coined the term Dinosauria, meaning terrible lizards, to categorize all of these prehistoric creatures.
Generally, the early paleontologists thought of dinosaurs as being large reptiles. And the problem with that is that introduces certain misconceptions. You start to think of dinosaurs as behaving the same way that modern reptiles behaved. And that clearly wasn't the case.
In 1854, Sir Richard Owen and artist Waterhouse Hawkins designed cement statues of the dinosaurs being found in England for the opening of London's new exhibition hall, the Crystal Palace. The sculptures still stand, but contain several anatomical errors. Both the Megalosaurus and Iguanodon were depicted as four-legged creatures. Later discoveries of more complete skeletons proved them to be bipedal. Putting the nose spike on the Iguanodon was another mistake. It turned out to be the creature's thumb. But to the general public, these anatomical errors hardly seem to matter.
What's really important about the Crystal Palace dinosaurs is the fact that they brought these animals for the first time to the public at large. People could go there and see them. They weren't scientifically accurate by any stretch of the imagination, most of them, but people could get a sense of their size and their majesty and the fact that these look like really strange, bizarre, alien creatures.
Dinosaur fever had begun. It soon spread to North America when the Wild West was found to be littered with fossils. Paleontologists had hit the mother lode, and the race to collect them would become known as the Great Bone Rush. Paleontologists that search the world for dinosaur bones are part scientist, part prospector, and part adventurer. Life in the field hasn't changed much, despite the many technological advances made over the last 160 years.
We use GPS to get our location. We use satellite imagery sometimes. We use helicopters to do a lot of digital photography, aerial photography. We use computers for all sorts of things. But basically, to dig up a dinosaur, you need a pick and a shovel and sometimes a jackhammer. I mean, and when you get close to it, you use little brushes and camel hair brushes and awls and masonry tools. I mean, it's really is still very basic.
In fiction, paleontologists have often been portrayed as mild, professorial eccentrics, or the ultimate big game hunters. In fact, the truth is somewhere in between. While many people may dream of becoming a paleontologist, it takes a special kind of person to devote his or her entire life to uncovering the secrets of the Earth's ancient past.
I traveled all around the world and met just about every working paleontologist there was in every country. And there's something that happens to somebody when they start thinking in deep time. They're sort of not of this planet. They're not of the same time-space continuum of the rest of us. They're thinking, you know, an idea of a long time is like, 65 million years ago, not what they had for breakfast.
Finding dinosaur bones is not all glamorous Indiana Jones type work. Field work, for instance, is extremely grueling. You can be up there at the crack of dawn, and then you're working out there in the hot sun all day long. It's very time consuming. You could be out there for a full season and not get anything except a tan.
Not all fossil hunters are paleontologists. This was especially true in the early years, when amateur or commercial collectors made some very important discoveries. But they often received little credit because of the mistaken notion that only those affiliated with established institutions could make significant contributions to science. One of the earliest of these commercial collectors was a woman named Mary Anning. She collected fossils around the seaside town of Lyme Regis, England, in the early 1800s.
She eventually put that town on the map by her knowledge of fossils and her collecting abilities, which was recognized by scientists from all over Europe.
She would go to the Natural History Museum in London, but her social position and her condition as a woman impeded her from getting into the circle of paleontologists in London that were studying all these fossils. And as she couldn't attend the university either, being a woman.
She kept on collecting fossils until her death. She died when she was 47 and had a marvelous career with many discoveries of animals from those cliffs in Lyme Regis, things like ichthyosaurs, plesiosaurs, the swimming reptiles that were so much loved by the public in the first part of the 1800s.
Another of the lesser-known but important early bone hunters was an English schoolmaster named Arthur Lakes. Lakes journeyed to America in the mid-1800s and made an incredible discovery near the small town of Morrison, Colorado.
He was hiking, he saw bones, pieces of bones that eroded out. They were gigantic bones. And he dug. And he made contact with museums back east. He got some advice, but basically he was self-taught. And he arguably is the greatest of the self-taught dinosaur hunters. And he brought back to life Brontosaurus and Apatosaurus and the first Stegosaurus, all of the wonderful beasts of the Jurassic period.
One of Arthur Lake's most important contributions was the scientific record he created. His drawings and watercolors helped identify the locations where he worked, and his detailed use of color indicated the types of sediments where the bones were found.
During his own lifetime, Arthur Lakes didn't get a huge amount of publicity, but he had a very good career here in Colorado. The big guys back east, Professor Marsh, Professor Cope, got most of the credit.
Othniel Charles Marsh and Edward Drinker Cope became, unquestionably, the two greatest names in 19th century paleontology. Famous for their important discoveries, and infamous for the highly publicized feud that developed between them.
Marsh was the head of Yale University's Peabody Museum, and Cope was the head of Philadelphia Academy of Sciences. You know, like all great rivalries, they started out as friends. And they were, go out in the field together, look for dinosaurs, look for fossils, and actually, name fossils, in honor of each other.
What set off their rivalry was the fact that Cope, who was very profuse in his publications about dinosaurs, had sort of rushed to publication this paper about an elasmosaur, which is a giant seagoing reptile with a long neck. And in his paper, Cope put the head of the elasmosaur on the tail instead of on the end of the neck. And Marsh was inelegant enough to point this out in public.
Having a mistake like this held up to public ridicule by Marsh was humiliating to a dedicated scientist like Cope. The gauntlet had been thrown down. The two men hired crews, headed west, and the Great Bone Wars was on. Their competition in the fossil fields of Middle America became legendary.
Luckily for science, it was one of the most productive feuds in history, because in that period of time, we're looking at 1860 to the 1890s, almost half of all the known dinosaurs of that period were discovered by O.C. Marsh and Cope.
The Bone War, which was actually a bone rush in a way, sort of wound down. Public interest had waned. Both men had spent vast amounts of their own personal fortune to sort of out collect each other. And they ended up in poverty, and it was really sad.
But even as death approached, Cope tried to continue the rivalry. He decided to donate his body to science and issued a final challenge that Marsh should do the same. Cope wished to have their brains removed and measured to see, once and for all, who had the superior intellect.
So he did this. He had his skeleton boiled down, and he had the brain preserved, which, unfortunately, though, I guess Marsh never decided to take Cope up on the bet and did not have his brain preserved. And so poor Cope's brain is now still sitting up there in the jar somewhere in Philadelphia.
With the passing of Cope and Marsh, dinosaur discoveries weren't headline news anymore. But soon, there would be a new invention on the scene, the movie camera, which would thrill the public in a whole new way and seemingly bring dinosaurs back to life.
Winsor McCay, who is a highly popular cartoonist, came up with the idea of doing an animated film, and he produced Gertie the Dinosaur. Gertie the Dinosaur was not only the first animated cartoon about dinosaurs, it was the very first animated cartoon ever.
Winsor McCay's choice of a dinosaur to star in his film was most appropriate. What better animal to bring to life on film than one which was extinct? With Gertie's debut in 1912, dinosaurs began to evolve in a whole new way. Into some of the biggest movie stars ever to appear on screen. By the turn of the 20th century, the notion that enormous creatures called dinosaurs once roamed the earth was readily accepted. The public was now ready for the next big thrill. That's when three men, Charles R. Knight, Willis O'Brien, and Roy Chapman Andrews, entered the picture. They succeeded in making paleontology exciting to the public and dinosaurs more than just some old bones in a museum.
Charles Knight was born in the 1870s, and since he was a child, he became interested in art and in animals. He studied art at the Metropolitan Art School and in the Art Students League in New York City. He also started spending a lot of time at the American Museum of Natural History in the taxidermy lab. He became well known among the scientists in the museum, who were very impressed with his curiosity and his serious interest in animals.
Charles R. Knight is probably the most important paleo artist who ever lived. He was really the artist who defined dinosaurs for the rest of the world. The reason his work had such an impact was twofold. He was not only able to convey the scientific information to the public, he did it in a powerful and dramatic way.
Knight went on to create an enormous body of work for museums in New York and Chicago. He also painted murals of the more recently extinct mammals that lived around the La Brea tar pits in Los Angeles. Knight's art created a new level of experience for the museum-going public. They could now see depictions of the animals in life, as well as the bones themselves.
He had a really important impact, I think, on the science also. I think that if you look at a lot of his paintings, one sees some things which weren't really prevalent ideas even at the time, but just because that he was such an expert in animal anatomy, he figured these things out. For instance, he had tyrannosaurs mounted much like our mounted Tyrannosaurus in, a horizontal position with its backbone parallel to the ground.
Charles Knight was a huge influence on movie makers, one of the main ones being Willis O'Brien. Willis O'Brien was the special effects wizard who created the dinosaurs for the 1925 Lost World, and he based all of his dinosaurs upon Knight's work. It was a way of bringing Charles Knight to the screen.
The Lost World was based on the 1912 novel by Sir Arthur Conan Doyle, the creator of Sherlock Holmes. The film tells the tale of an expedition to a remote part of the world where dinosaurs had survived extinction. The Lost World made some of the same mistakes that almost all dinosaur films have made ever since. In the film, species from the Jurassic and Cretaceous periods interact, even though they existed millions of years apart. Also, the size of the dinosaurs was often exaggerated. But in several ways, The Lost World was ahead of its time. In his quest to bring drama to his film, Willis O'Brien created dinosaurs that, in many aspects, are now seen as being more accurate than the scientific opinion of the 1920s.
One of the things that really interests me about paleontology is when non-paleontologists get involved with it and actually provide speculations that the paleontologists may have overlooked. An example of that is in Lost World with the protective Triceratops. At the time, the general perception was that dinosaurs were too stupid to have any kind of organization or protection or society, that they were just born and then went off on their own. And in the film, a mother Triceratops gathers and protects her young. Well, that's very forward thinking if you think that we really didn't discover evidence of that until the late 1970s and 1980s.
I vividly remember seeing Willis O'Brien's The Lost World in 1925, and that stuck in my mind for years, this dinosaur particularly falling off the cliff. Of course, at the age of 5, it's hard to distinguish reality from fantasy. So I thought it was real. Apparently, Conan Doyle showed a group of scientists, and everybody thought it was real because no one knew much about stop-motion photography at that time. So the dinosaurs were considered a real image on the screen.
One of the reasons people believed that these dinosaurs were real was the primitive technology of filmmaking back then. The dinosaurs were just as jerky in their movements as a lot of the people in some of the shots. And so there was a consistency, an overall consistency to the film product that people were viewing.
For some audiences, the creatures on screen seemed even more realistic because the newsreels of the era often featured the exploits of a real-life dinosaur hunter named Roy Chapman Andrews.
Roy Chapman Andrews was an incredibly colorful person. He was swashbuckling. He traveled all over the world. Anyone who's seen images of him knows that he had a big impact on sort of popular culture of the 20s and 30s. He may have been some of the inspiration even for Indiana Jones in the sense that, he wore a fedora, he always carried a 6-gun, he wore high boots and a leather jacket in the desert all the time.
Andrews became the world's most famous dinosaur hunter in an unlikely way. He really wanted to work at the American Museum of Natural History in New York, but lacked any real qualifications. So he started there as a janitor and eventually worked his way up to curator. Andrews' drive and charisma made him the perfect figurehead for an ambitious expedition to Asia to look for the remains of early human beings.
And once again, as it has happened a number of times in paleontology, serendipity played a major role there, and they didn't find any remains of early humans, but they found some tremendous dinosaur remains, some fossils that clearly changed, once again, the history of dinosaur paleontology.
The discovery of dinosaurs in Europe, Africa, America, and now China had a powerful effect upon the general public. People were amazed that these incredible creatures had once roamed the entire world. The museum's trips to China and Mongolia became known as the Central Asiatic Expeditions. During the trek in 1923, Andrew's expedition became renowned for discovering a nest of eggs, thought to be those of a Protoceratops.
However, Roy Chapman Andrews really wasn't a great scientist, and that everyone credits him with these great dinosaur discoveries. He was a wonderful expedition leader, but he actually never even published a single paper on dinosaurs themselves. The chief paleontologist was a man named Walter Granger, who was in the Department of Paleontology here at the American Museum, and he really was a scientist, and he actually is the one who I think should be credited with the great scientific successes of the Central Asiatic expeditions.
What Andrews lacked in scientific expertise, he made up for in another important aspect of museum survival: fundraising.
Because these things are very expensive. The Central Asiatic expeditions in the 1920s, when you look at the costs, they're quite impressive. We're talking about hundreds of thousands of dollars. The first expedition that used a whole fleet of motor cars in combination with 100 camels is a pretty dramatic affair. So he knew how to do that, and he knew how to promote an expedition and raise the money for it.
One of the things that made Roy Chapman Andrews very effective in raising funds for the museum is that he was one of the first paleontologists to take along a movie crew. And those films got sent back to the United States and became parts of newsreels and made Roy Chapman Andrews famous, made the American Museum of Natural History even more famous, and was instrumental in piquing public interest in paleontological adventures.
Chapman's fame proved how important the media could be in raising interest and funds for further exploration. But due to circumstances completely outside of his control, the Central Asiatic expeditions came to a quick and unexpected end.
By the end of the 1920s, because the political climate was changing, the American Museum was basically thrown out of China and of Central Asia and not allowed to work there anymore.
As the Roaring Twenties came to a close, Charles R. Knight was still painting, and Willis O'Brien was trying to launch a new dinosaur film project. But the Great Depression and the coming war in Europe would make it increasingly difficult to keep dinosaurs in the public eye. By the end of the 1920s, the search for dinosaurs had suffered a 1-2 punch. The American Museum of Natural History's expeditions into Asia had come to an end because of political unrest in that part of the world. And with the onset of the Great Depression, funding for dinosaur projects had practically dried up. One of America's most prolific dinosaur hunters, Barnum Brown, did manage to get further exploration underway by finding sponsorship from Sinclair Oil, which in 1930 adopted a dinosaur as its company logo. But over the next 40 years, dinosaurs remained in the public eye primarily through the movies. Ironically, it was a great ape that gave them their most memorable starring role.
Looking back on it now, we are tainted by what we've seen today, but for the day of King Kong, it was the most spectacular event ever to come on the screen.
King Kong premiered in 1933 and was the Jurassic Park of its era. Kong lived on a tropical island filled with survivors of the Mesozoic. The special effects were designed by Willis O'Brien, whose on-screen creations were influenced by more than just science.
Willis O'Brien in his early days was an amateur boxer. He used to go to the fights a lot. He put a lot of humanoid elements in Kong, as well as the dinosaur. He had this great giant gorilla boxing a Tyrannosaurus and using similar techniques as they use in The Ring, which I think was half the charm of that sequence.
When Kong was first released, scientists must have scoffed at the athleticism of O'Brien's creations. But once again, as in his work for The Lost World, the behaviors of O'Brien's dinosaurs are now considered more accurate than when the film was made.
I think in a lot of ways King Kong was ahead of his time, especially with the fight between Kong and the T-Rex, in that O'Brien portrayed a very active Tyrannosaurus Rex. It wasn't a slow, sluggish dinosaur. It was a scrapper.
When I was a kid, my favorite dinosaur was Brontosaurus, and that's because of King Kong, where the sailors on the boat see the head and neck of a brontosaur and yell at it and start shooting. And all the sailors run across the sand, and they're pursued by the brontosaurus on land, who's moving at a good clip. That was in 1932, those shots were made. And at that time, scientists disagreed. They said Brontosaurus could never get out of the swamps. It was a slow-moving guy, inoffensive, dumb, a pushover. Well, I'll tell you, Willis O'Brien was right. By gum, they didn't live in swamps. So King Kong, Bronto was right. PhDs at Ivy League institutions were wrong.
King Kong was a huge hit and influenced many budding filmmakers, including young Ray Harryhausen. The film inspired him to spend his teenage years learning to draw and experimenting with stop-motion animation in his garage.
I wanted to do something with dinosaurs, and I got the concept of the evolution from books that I'd read, and I wanted to develop a whole story about the starting of the world. It was very ambitious for a young amateur to try or even think of. And then Fantasia came out, and here are these wonderful dinosaurs done in cartoon style, so I never finished Evolution. Walt Disney beat me to the punch, yes.
Walt Disney's Fantasia was another enormous influence on future paleontologists. It also offered graphic evidence that scientists weren't the only ones presenting incorrect information about dinosaurs.
The Rite of Spring sequence, which featured a sort of compressed history of life on Earth, really reached a lot of people. Although it's highly inaccurate, there were all kinds of groups of dinosaurs that did not live together at the same time. And there was also the demise of the dinosaurs blamed on everything getting hot and drying out, which we know is not true. It was so beautifully staged and so dramatically animated that I know, as a dinosaur fan myself, it was enormously influential.
It would be almost a decade before dinosaurs would star in another film. Modern monsters of World War II made devoting any time or money to the study of dinosaurs an even lower priority. Ray Harryhausen had to put his plans on hold while he served in the Army Signal Corps. A few years after the war, low-budget filmmakers decided to bring prehistoric monsters back to the theaters. But their paltry budgets led to some pitiful dinosaurs.
A lot of times it was men in Tyrannosaurus suits, such as in Unknown Island. Other times we got a little luckier, and people like Ray Harryhausen would come up with a film like Beast of 20,000 Fathoms in 1953 and do beautiful stop-motion animated dinosaurs.
I didn't want to make it like The Lost World, or the people would think we were making a remake of The Lost World. I didn't want it a Brontosaurus, I didn't want it an Allosaurus or a Tyrannosaurus. So I had to concoct my own image. So we gave it a different design so that it would be more, shall we say, copyrightable.
No one could question the accuracy of Harryhausen's creature, a creation of his own imagination. The film was a big success and launched the giant monster on the loose film craze of the 1950s. Across the Pacific, another dinosaur revived by radioactivity was terrorizing Tokyo. Godzilla, played by a man in a suit stomping on miniature buildings, was supposedly a 400-foot-tall beast from the Jurassic.
I think the original film touched on something special because Godzilla, according to the story, was created out of radioactivity, sort of resonating with the recent history of Japan, having been bombed in Nagasaki and Hiroshima. Godzilla later developed from being a villain into being almost a folk hero, in Japan at least, almost in a religious sense, and spawned dozens and dozens of Godzilla films.
In the early 1960s, with little news from the scientific world, prehistoric pop culture began to be targeted more directly at children. Movie producers found a new way to get people back in the theaters again by combining dinosaurs with attractive and underdressed cave people.
So they found an old property that had been made in 1940 called 1 million BC and decided to remake it. And not only did it feature the spectacular attributes of Raquel Welch as Lowana the Fair One, it also had some of the screen's greatest stop-motion dinosaurs by Ray Harryhausen.
It's often debated whether people went to see the film for Raquel Welch or the dinosaurs.
The original film used live lizards photographed to look gigantic. So in the remake, Harryhausen decided to carry on the tradition.
My theory at that time was, let's try a real lizard for the first sight of the dinosaur, because then the audience will believe the rest of it. But that was unfortunately a bad decision. We got a real lizard, and under the hot lights, he just fell asleep. So the lizard handler had to move him almost like a hand puppet, and it got ridiculous. We shot thousands of feet because they just don't act.
Fortunately for Harryhausen, his stop-motion animals could act, and 1 million years BC was a hit. Harryhausen's next project was The Valley of Guanji, but the film did not enjoy the success of his earlier efforts. It was released in 1969, a rebellious time when the past, even the distant past, seemed irrelevant.
I'm afraid that the public lost interest when we released Guanji because outer space was becoming very popular and everybody jumped on the bandwagon. So I wish we had made Guanji about 5-6 years earlier. I think it would have been a much bigger success than it was.
Despite the occasional failure at the box office, all of the attention given to dinosaurs in the movies and pop culture put them back on the map. For 40 years, the search for dinosaurs had been limited and virtually ignored. But a love for these incredible beasts had been planted in a new generation of budding paleontologists.
Well, like a lot of kids, I got interested in dinosaurs when I was very young. In fact, I was 6 years old. And it came from opening up a box of cereal, and there was a plastic dinosaur inside, and that started me off with this overwhelming fascination of those animals.
When I was in the 4th grade, I made my first museum trip, and there I saw an Allosaurus, whole skeleton, mounted, crouched over its prey, brontosaur backbone. And I read the label, and it said, dug at Como Bluff, Wyoming, and I told my startled parents I was going to be a paleontologist, and I was going to Wyoming. And this guy is another Allosaurus from Como Bluff, same species as I saw mounted in New York in 1954. And my crew, my students dug it up. Makes me very proud.
The previous generation of paleontologists was passing on, just in time for this new crop of dinosaur hunters to amaze the world with new discoveries and theories that would blow the lid off the way we viewed these remarkable beasts. 'Cause 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 'c By the late 1960s, paleontologists had been presenting dinosaurs in the same way for more than half a century. But a new generation of fossil hunters was about to forever change our old ideas about these ancient creatures.
Dinosaurs had been portrayed as big, lumbering, stupid lizards, kind of, walking around looking for a place to go extinct. And in the late 60s, John Ostrom at Yale University actually found a dinosaur that he named Deinonychus, aka Velociraptor in Jurassic Park. He started looking at the bones of this Deinonychus and he realized that it shared a lot of characteristics with birds, with Archaeopteryx. And so it was the late 1960s when the perception of dinosaurs as stupid reptiles started to change.
The discovery of the first Deinonychus was a momentous occasion. But it would take a rebellious and controversial paleontologist to turn the study of dinosaurs completely upside down.
Bob Bacher is a person like that comes around once every couple generations. A lot of what he says, maybe it doesn't become fact, but by God, people will spend their entire careers maybe trying to prove him wrong only to find out that he's right.
When I started publishing papers in the late 60s and 70s, I did something heretical and shocking, and I was roundly condemned for it. I took a dinosaur like this allosaur, and onto the arm, I stuck not lizard scales, but bird feathers.
Through the 70s, Bob Bacher started talking about the possibility of dinosaurs being warm-blooded, and John Ostrom discovered that dinosaurs didn't drag their tails. So there was a beginning of a shift, kind of a paradigm shift, where people were beginning to see the possibility that dinosaurs were a lot different than they had been perceived.
To this day, no one knows for sure whether dinosaurs were warm-blooded or cold-blooded. But there is no denying that at least some of these animals were social creatures. Perhaps no single discovery did more to change the perception of dinosaurs and capture the imagination of the public than Jack Horner's work at a Maiasaur nest site in Montana.
As we found more and more individuals and finally found eggs, we're able to actually hypothesize that these dinosaurs had been cared for because we knew that these 15 dinosaurs were at least twice as big as they had been when they hatched out of the eggs. So they had hatched out of their eggs, they had grown, they had doubled in length, and still were in a nest-like structure. And so the most reasonable and the easiest answer to explain that would be that they had hatched out of their eggs, they had stayed there, a parent had brought food to them, and they doubled in length within some period of time.
Jack, he's really is sort of the man in the forefront of dinosaur behavior with his work with Maiasaurs. Maiasaur means good mother lizard, and that's because he found these sort of juvenile dinosaurs in the nests and figured, well, they were being raised, which is fascinating when you think about it. I mean, that you're able to determine 65 million years later that dinosaurs took care of their own. That's amazing.
The new breed of dinosaur hunters began clearing up other misperceptions as well. The discovery of several new species made clear the full range of dinosaur dimensions. While some were far smaller than ever previously imagined, others were positively enormous.
The word dinosaur conjures up bigness, size. Most people think of these things as being huge, big animals. Indeed, the early dinosaurs that became known to the public were big, big animals. Later, paleontologists started to discover the giants. So names like Supersaurus, Ultrasaurus, and finally Seismosaurus, the beast behind me, became known to the public. Seismosaurus was 137 feet long, 23 feet at the hips. But is this the biggest? We don't know. The odds are that these dinosaurs probably grew throughout their lives.
During this period of revisionist thinking, the study of dinosaurs was also shedding light on the bigger picture of how different our Earth was millions of years ago. In the 1980s, scientists discovered dinosaurs in a most unlikely place, Antarctica, paleo artist William Stout traveled there to confer with paleontologists and created visions of a very different Antarctica than we know today.
In 1986, the very first dinosaur from Antarctica was discovered. It was a kind of ankylosaur, one of the armored dinosaurs. In 1994, William Hammer discovered the first dinosaur on mainland Antarctica, a dinosaur known as Cryolophosaurus. It was similar in appearance to Allosaurus, except it had a bizarre crest made of bone on its head that looked like sort of like a Spanish comb. Very weird animal. What a lot of people don't realize is that Antarctica hasn't always been frozen. And in fact, in the Triassic, it was covered with lush swamps and jungles, very warm.
Around the same time the dinosaurs were first being discovered in Antarctica, something else was making headlines. A new theory about the cause of dinosaur extinction. In the past, the dinosaur's demise was blamed on such factors as climate change, disease, or simply growing too big for the available food supply. But this latest theory was an intriguing new idea to scientists and captured the imagination of the public.
A scientist named Luis Alvarez presented a theory that dinosaurs may have been destroyed by a kind of nuclear winter created by the collision of a giant asteroid with the Earth. He came to this conclusion because he found iridium, which is an element usually found only in meteors or in volcanic rock. This led to the hypothesis that it was this asteroid had collided at the end of the Cretaceous period, which sent up this cloud of dust and debris, and not to mention an awful lot of destructive energy, which darkened the sky and basically caused the dinosaurs to become extinct.
Most skepticism about such an impact was put to rest when a giant crater was discovered in Mexico's Yucatan Peninsula. But there are many paleontologists who question whether this really is the smoking gun of dinosaur extinction.
But it seems like the more that we've looked at this problem, the more complex the problem has become. Because although the asteroid theory is satisfactory in that there's a reason, that there's an actual mechanistic bad thing that happened 65 million years ago or so, it doesn't explain a lot. And one of the first things it doesn't explain is just how selective the extinction seems to be.
The Cretaceous world, the dinosaur world, was warm and tropical, full of dinosaurs, big guys, full of salamanders and lizards and crocodiles and some snakes. If you dump cold, acid rain into a tropical pond right now, you kill right away the frogs. You kill right away the salamanders. A little later, you kill the turtles and the crocodiles. They're very vulnerable to acid rain and cold. So, okay, maybe a meteorite hit. And okay, there was a cloud of acid rain, and it got cold. Who should die? Who should be the VICs? Salamanders, frogs, lizards, snakes, gators. Who didn't die? Salamanders, frogs, lizards, turtles, gators. The wrong victims died.
Despite these remarkable discoveries, the entertainment and publishing industries only cautiously began to reinvest in dinosaurs, for the first time in nearly 20 years. Again, they targeted the demographic that never seems to lose interest in these remarkable creatures. A trickle of toys, books, and videos began to appear, and soon became a flood. But by the end of the 1980s, it was questionable just how long the dinosaur revival would last. Photojournalist Luis Cejoyos was interested in publishing a book of the photographs he had been shooting for National Geographic. But his publisher was less than enthusiastic. Market research showed the dinosaur craze winding down.
Then I met a fellow gentleman on a plane who asked me what I did. I told him I worked for National Geographic and was working on a story on dinosaurs. And he says, "Oh, that's interesting. A friend of mine is doing a movie on dinosaurs." I said, "Who's your friend?" He says, "Steven Spielberg." He says, "He loves National Geographic. Would you want to photograph the dinosaurs?" So I went out and saw Stan Winston's studio. And I saw the dinosaurs. And I got on the phone and I called National Geographic up and I said, "Forget your market survey. There's gonna be a huge resurgence in dinosaurs. These things are alive." You know, I just saw them out of Stan Winston's studio.
Michael Crichton's techno-thriller Jurassic Park was being brought to the screen by Steven Spielberg. Fortunately, the planning of the film coincided with the refinement of computer animation and state-of-the-art special effects. Spielberg also wanted to make sure his dinosaurs were scientifically accurate, at least to date. He asked Jack Horner to serve as an advisor.
I accepted and worked with Stephen directly and worked with Stan Winston. And my job really was to make sure the dinosaurs were accurate enough so that sixth graders didn't send Stephen nasty letters. There was a time when Stephen wanted the dinosaurs to, have a forked tongue, and I told him he couldn't do that because we know that dinosaurs didn't have forked tongues.
Jurassic Park became a phenomenon and created a franchise for Universal Studios. Dinosaurs were now among the highest-grossing movie stars of all time, and suddenly they were everywhere. Museums benefited from the surge of popularity as well. Attendance was up, new exhibits could be built, and most important of all, funding was now available for new explorations. Just what would be discovered was anybody's guess. Thanks to the boom in interest in dinosaurs that began after the release of Jurassic Park, there is now more paleontological research going on around the world than ever before. Much of the work has focused upon re-examining many of the questionable conclusions that were reached in the past. Most paleontologists now view dinosaurs as more bird-like than lizard-like, more agile than plodding, more social than solitary. At the same time, scientists have given themselves the difficult challenge of looking beyond the size and shape of dinosaurs to learn more about their behavior. Much of this work revolves around the study of dinosaur tracks.
When you look at footprints, very often what you're looking at is evidence of what the living animals were doing. When you see footprints walking across the mud, for example, you can see how that animal walked, how it held its body, whether or not it dragged its tail.
You can, put your feet in its place and figure out how long its stride was. There's a trackway out in Arizona where you couldn't run that fast. We've determined that it was going something like 27 miles an hour. You can tell a lot about dinosaur behavior. You can see how they're walking next to each other at the same moment in time, where one's sort of like two people walking down a New York sidewalk, they'll move to make room for somebody else, and then the whole crowd will move around it.
Some footprints reveal a dramatic moment captured in time. These tracks outside of Denver, Colorado, show a herd of plant eaters traveling forward as they are set upon by meat eaters who attack from the sides.
Footprints are incredibly important because they test theory. A lot of theory in my science is, well, dinosaurs couldn't do this and they couldn't do that. Footprints tell you what they actually did.
Paleontology has always been a little bit of forensic science because, what you're doing is you're looking for the clues to why something died, in this case, 68 million years ago. And you're going through all the evidence and you're trying to find out who the culprit was and what the cause was and what the scene of the crime was like at the time those animals died and what happened immediately after they died. So being a dinosaur paleontologist is just like being a detective.
As the approach to paleontology has evolved from bone hunting to evidence gathering, many scientists have decided to revisit old dig sites. Their goal? To discover fossils and paleontological evidence that may have been overlooked in the rush to excavate the bones.
In the very beginning, it was because there was so little known about these animals and there were so few good skeletons, there was a real focus on collecting a lot of complete specimens and getting them on display as quickly as possible.
One of the tragedies of the old days of collecting was the fact that they had so much opening up in front of them that they were overworked. And this was certainly true with Barnum Brown. He was collecting up to 4 boxcar loads of dinosaurs every season that he spent in Alberta and shipping them back to New York. And by the time those specimens got prepared and illustrated and so on, he was a very old man.
Phil Curry first became interested in Barnum Brown's work in the early 1990s.
When Dr. Curry examined some of the specimens that Barnum Brown collected at this site, he realized that there were partial skeletons of several different animals from this one site. And that immediately suggested to Phil that he should go back to that site and excavate it to try and determine how many animals were there. And it would provide evidence that these dinosaurs, Albertosaurus, actually lived in groups and may have exhibited pack behavior.
Tracking down Barnum Brown's old site near the Red Deer River in central Canada took some detective work. Curry made several visits to the archives at the American Museum of Natural History, but could only find a few photographs of Brown's 1910 exploration of the area. This was all he had to go on as he attempted to follow in Brown's footsteps almost a century later.
When I came up to this ledge, finally I knew I had the right spot, because in the photograph Brown took, there's this very distinctive ridge right here with the trees behind it. And there's only one ridge like that in this whole region, and that's the one that's behind us right now. The trees are almost in exactly the same place. All of the hills line up and match. The only real difference is that on the skyline, now there's a little stand of poplar trees on the edge of the prairies. That wasn't there when Brown was there.
Dr. Curry's search paid off. Over the past few summers, he and his crew have expanded Barnum Brown's original site and have found the remains of at least a dozen Albertosaurs, a close relative of T-Rex. The question is, what killed them off?
When we look at not just the distribution of bone, but the things that are associated with it, we see that there's lots of plant material mixed in with the bone. So these are bones, and these are logs. And really, it's like a log jam. What that suggested to our sedimentologists is that there was some kind of major storm event, such as a hurricane here at that time. And it may have been what caused the death of this group of Albertosaurus. We're not really sure, though. One of the things we did recover, for example, was charcoal. And charcoal is a good indication that there was a fire. And forest fire, of course, is another possible explanation for a catastrophic death of this pack.
Phil Curry's work has provided a context for much of Barnum Brown's work. But Curry isn't the only paleontologist revisiting old sites and sometimes correcting the mistakes of the past. In the 1990s, Mongolia was reopened to American scientists. Paleontologists with the American Museum of Natural History returned to the sites that made Roy Chapman Andrews famous. They soon found that one of Andrews' most renowned nest site discoveries had been misinterpreted.
Now, this oviraptor was found lying on top of a protoceratops, a so-called protoceratops nest. And they named it oviraptor because it means egg thief or egg eater. So their interpretation at the time was that this animal had perished while it was eating this nest of protoceratops eggs.
That identification stood for many, many, many years. And then recently, Mark Norell and Mike Novacek went to Mongolia and did a series of dinosaur digs and found many, many, many more egg nests, including eggs that had embryos in them. And when they examined the embryos of the eggs that Roy Chapman had identified as being protoceratops eggs, they found that instead of being protoceratops, they were oviraptor.
Advances in technology have enabled today's scientists to correct Roy Chapman Andrews' misinterpretation.
So really what had happened with the original specimen of oviraptor that had been collected was that animal was probably a parent of that nest, and it just died on top of the nest instead of predating on it like the prevailing idea of the time was.
Other parts of the world, such as South America and Africa, have also yielded an abundance of fossils. Paleontologist Luis Chiappe has led the Los Angeles Museum of Natural History's expeditions into the Patagonian region of Argentina. His discovery of thousands of eggs from dinosaurs known as sauropods has corrected a commonly held theory.
We know that they're sauropods because, like the case of oviraptor, we have eggs that contain the embryonic remains of sauropods inside. In the past, the idea that was held by a number of people during the history of vertebrate paleontology. They thought that sauropods did not lay eggs, that they probably gave birth to live young. And now we can certainly rule out that view.
Luis Chiappi is quick to point out, however, that the large Apatosaurus-type sauropod mother would have been much too heavy to sit on her eggs.
You have to think about an animal that laid a clutch of maybe 30 or so eggs, a clutch that had about 4 or 5 feet in diameter, but the animal, the parent, the female, was probably 50 feet in length and had a weight of maybe 10, 15, or 20 tons. So I don't think that we're going to find an animal, one of those females, sitting on top of a clutch of eggs.
Today, new discoveries like those in Patagonia are being made on a consistent basis, thanks to the continued attention that dinosaurs have been receiving. But success has its downside. In October of 1997, the fossil skeleton of a T-Rex named Sue sold for $8.5 million. This immediately opened the door to amateur collectors, get-rich-quick schemes, and additional paleontological mistakes.
I'm not sitting here trying to blame anyone for it, but $8.5 million brought a lot of people out of the woodwork that thought, well, gee, you know, if I could find a dinosaur, I could get rich.
Some commercial collectors are highly ethical and make very careful documentation of whatever they find, but others are not. Others are what we call headhunters. They know that a skull will fetch much more than a skeleton or parts of a skeleton. And so often they will go and they will find a dinosaur skeleton, just take the head.
In a zeal to just simply get something because it looks good and it'll sell for a lot of money, those kinds of important data are lost. And we have no scientific record of what might be an extraordinary specimen.
By the end of the 20th century, dinosaurs and dollars had become so intertwined that fake fossils began to surface.
There was a fossil that I guess was acquired from China under mysterious circumstances and turned up at a gem and mineral shell, which seemed to be the real missing link between dinosaurs and birds. It looked like it was half dinosaur and half bird. Some notable paleontologists actually were quoted making statements to that effect. National Geographic got involved and did a story in which they ran beautiful color photos. Well, it turned out, this half dinosaur, half bird, it turned out that's exactly what it was. It was a forgery made by someone in China for gain.
In recent years, paleontologists have also been in competition with members of the public who have learned where fossil sites are located and come looking for souvenirs. The public's interest has given rise to commercial dig sites. Here in Thermopolis, Wyoming, anyone wanting to experience the thrill of unearthing fossils is transported to a working site, given a quick lesson in basic field technique, and then allowed to begin digging. While some in the scientific community have mixed feelings about these businesses, at least if anything significant is found, it becomes the property of the local museum. But between erosion, amateur collectors, and second-rate science, it is impossible to determine what irreplaceable pieces of the paleontological puzzle have been lost forever. Fortunately, scientists armed with new tools and technologies are working to fill in the gaps. More than a century has passed since dinosaurs first became part of our popular culture. Since then, they have been transformed into a different kind of beast. They are no longer the dull-witted, slow-moving, overgrown lizards that slipped into extinction. Now they are seen as dynamic animals, more bird-like than lizard-like. But that doesn't mean our perception of dinosaurs won't change again.
That's the exciting thing about dinosaurs. There is such a diversity of structure, of form, and function for their bodies that every time we think we know it all, we find that we've probably missed something. So we have to be very careful not to be too dogmatic, because after all, that's science is never supposed to be dogmatic. We're supposed to be open to surprise and be willing to change our minds at the drop of a hat.
For scientists, keeping an open mind means avoiding making any sweeping generalizations.
For example, working with the herds of ceratopsian dinosaurs down in Dinosaur Park, it shows us that many dinosaurs probably traveled in packs or herds. But that doesn't mean that all dinosaurs did that, and we have to guard against those kinds of changeovers in our thinking where suddenly we jump from one misconception and create a different misconception altogether. Dinosaurs were very much like living animals. They practiced a whole variety of lifestyles.
There also appears to be a wide range in dinosaur intelligence. With the discovery of many small meat-eaters with relatively large craniums, modern revisionist thinking has presented dinosaurs as much smarter animals than originally thought. But that doesn't mean all dinosaurs were bright. The huge herbivores of the Jurassic period were anything but intellectual giants.
These animals were dumber than lizards. They had smaller brains than their ancestors. It's a case of Darwinian dumbing down. And I think, actually, it's evolutionary brilliance. These guys had very long necks. They had a big brain. When they lifted their head really, really, really high, they'd have to pump blood at tremendous pressures to get blood into their big brains. By having a tiny brain, they could go without any blood flow at all when they lifted their head high. They could feed for a couple of minutes, lower the head, get some blood in, and go up again. Brain is a greedy organ. A big brain needs blood all the time. A tiny brain frees you up. So sure, they were stupid, but the stupidity was part of a brilliant plan. We do call the Jurassic the Moranozoic. At no time before or since has the average big plant eater been so incredibly stupid.
Today, paleontologists are also careful to quickly point out where knowledge ends and conjecture begins.
A lot of things that we think we know about dinosaurs, really, we don't know for a fact. This whole controversy about whether they were warm-blooded, cold-blooded, or maybe a combination of the two, or maybe some were warm-blooded, maybe all were cold-blooded. That probably will never be proven unless, again, you see a live dinosaur. You can stick a thermometer in its mouth to take its temperature.
A lot of people ask you, what color is a dinosaur? And the reality is, at least at this point in time, we don't know. We have no idea what color they were. So there's a very great range of fanciful reproductions. They may be correct, you know, may be correct that some dinosaurs were purple with pink polka dots, but in truth, we have no idea.
There's probably a lot about dinosaurs we'll never know that affected their physical appearance. Look at a chicken, the comb on a chicken, or a hump on a camel. It's very likely that dinosaurs had all types of spiny things and fancy things that have not been preserved in the fossil record, that if we saw a dinosaur in the flesh, would make them appear quite different than you see in all the reconstructions. Most of the reconstructions that you see, the life restorations, are fairly conservative.
Many modern paleontologists are not as conservative as their predecessors. They are willing to push the envelope and explore theories that would have been considered outlandish in the past.
Here's the head of Brontosaurus, close kin of Apatosaurus ajax. That's the eye socket here. The ear was here. That hole is for air. This hole, this is a great hole. It's an important hole. Major nerve and artery comes out of here, and it's a huge hole. A lot of blood was going to soft tissue here. Not a scaly skin, but something else. Now, way back, 70 years ago, someone said, hey, look at this. The nostrils are between the eyes like an elephant. Maybe it had a trunk, and everyone laughed. Wait a minute. There was something here, something muscular, that required a lot of blood flow. By gum, I think this is another idea that needs to be resuscitated.
Behind me is where the creativity is kind of exploding. We have a beast that's got all kinds of colors and stripes and patterns. And beyond that, behaviorally, we have a beast that some paleontologists think may have spitted or sprayed poison.
In the past, Hollywood was often accused of taking dramatic license with the design and behavior of dinosaurs. But in recent years, it's the movies that have tried to keep pace with the science.
Fortunately, we keep discovering new things. And when the first Jurassic Park came out, we were pretty certain that birds were dinosaurs, but we hadn't convinced a lot of people. In the movies, we see modern understanding of what dinosaurs look like. And it's still a little behind time. I mean, I would prefer to see the velociraptors fully feathered.
In the third Jurassic Park, we didn't go to feathered dinosaurs just because there didn't seem to be the proper place for it in this particular movie. The character wasn't written. The closest thing we got to it was actually adding quills to the male velociraptor. So in Jurassic Park 4, when we do the feathered dinosaur, well, I'll be happy to put the feathers on. There was no compromise. It was never actually a thought.
The Jurassic Park dinosaurs were brought back to the modern world through cloning. When Michael Crichton published the original book and the first movie was produced, cloning was still science fiction. But now it has become a reality. Does that mean dinosaurs are really going to walk the earth again?
We can clone a sheep and call it Dolly. In the case of cloning today, we actually combine egg with the complete genetic material of another individual. We're working with live creatures to do this.
However, as far as bringing one of these animals back to life, a la Jurassic Park or anything else, is pretty unlikely, simply because that although you may find DNA in one of these organisms, in the bones or the teeth or something, that DNA is probably degraded so much that you could never put it back together again into genes.
I am very happy that dinosaurs are extinct. I don't want to see anyone clone them again. I don't want to bring them back. I like getting out of my truck and going to my house, not having to look around to see if a velociraptor is going to jump on me.
It is probably a good thing that dinosaurs are creatures of the distant past, and that paleontologists, not zoologists, will continue to study them. And now, more than ever, scientists are equipped to decipher the remnants of the Mesozoic era.
Right now, the really exciting thing in dinosaur paleontology is the use of new technology to answer some old questions. That we have instruments now where we can do isotopic analysis of bones, which may tell us something about diet or warm-bloodedness. We're doing histological, which means like looking at very fine-grained sections of bones to find out how fast dinosaurs grew, how old they may have gotten. So I think that these new technologies are really going to change our view of dinosaurs in the next 10 years as much as the amount of collection activity over the last 10 years has.
It is estimated that a new dinosaur species is discovered every 7 weeks, and that 99% of all species have yet to be found. To those who have dedicated their lives to uncovering the truths about these ancient beasts, it is clear that after 160 years, paleontology has only begun to scratch the surface, and there will be many more twists and turns down the rocky road of dinosaur discovery.
Everything we do in paleontology is disproven sooner or later. That's what it's all about. When we first make discoveries, we have the least amount of information that will ever be known about that particular subject. As you get more information, then you can modify your hypotheses and falsify some of the old ones. And there's nothing wrong with that. That's good science.